Hello and welcome to my channel. In this video we are going to solve the 6th question from 058041 extended paper October-November 2024. Now this question is from trigonometry topic. The diagram shows a field ABCD. A straight path AC goes across the field. Show that the length of AC is equal to 1028 meter. Correct to the nearest meter. Now here in this question a field is given in the shape of ABCD. And there is a straight path which connects the 2 points A and C. We have to find out the length of AC. So to find out the length of AC, we are going to consider the triangle ADC. Now in this triangle ADC, we have the value of AD, we have the value of CD, and we have the angle between these two sides, that is angle ADC. Since we need to find out the length of the side opposite to this angle, we are going to make use of the cosine rule, which is AC square, that is the length of the missing side, is equal to the sum of the rest two sides squared, that is AD square plus DC square, minus 2 times AD times DC times cosine of the angle which is opposite to the missing side, that is cos of angle D. Now let us substitute the respective values. Now in the next step we have taken the square on the other side of equal to sign. So it becomes square root of AD square. AD is 420, so we have written 420 square, plus DC is 830, so 830 square minus 2 times 420 times 830 times cos of angle D is cos 106. Now let us see what value this gives us. So this is going to give us the value as 1028.3357. Now since we have to round it to the nearest meter, we are going to round it as 1028 meters. So we have shown that the length of AC is 1028. Let me write here. Now this is the value of AC. Now let us move on to the next question. Angle ACB is obtuse. Calculate angle ACB. So let us reconsider the figure over here for easy reference. So this is the same figure we have reconsidered, and the value of AC I have already written over here and considered it as 1028 meter. Now here we need to find out the angle ACB, that is this angle. And a hint given over here is angle ACB is going to be an obtuse angle. Obtuse angles lie between 90 and 180 degree. So let us see what value we get here. So to find out the angle ACB, we are now going to consider the triangle ABC. Now in this triangle, we have the value of angle B, that is 62 degree, and the side opposite to it is also known, that is AC, 1028 meter. Now we have to find out the value of angle ACB, and the value of the side opposite to this angle is also given, that is AB, 1150 meters. So in this case where we need to find out one angle, and we have two sides with us and another angle, we are going to make use of sine rule, which is sine of the missing angle ACB over the side opposite to this angle, which is AB, is equal to, now take the sine of the angle which is given in the triangle, that is sine of angle ABC over the side which is opposite to this angle, that is AC. Now since we need to find out the value of angle ACB, I am going to multiply AB with the right hand side. So we get sine of angle ACB, which we need to find, is equal to, now AB I have taken on the other side of the equal to sign, and at the same time I have substituted its value, that is AB is going to be 1150 as written over here. Now let us consider this fraction. Sine of angle ABC is going to be sine of angle 62 over AC value is going to be 1028. Now in the next step I am going to send the sign on the other side of equal to sign. So we get angle ACB is equal to sine inverse of this right hand side. Now let us see what value this gives us. So this is going to give us the value as 81.0164. So let me write it over here. Here I have rounded this value to 2 decimal places and written the value of angle ACB as 81.02 degree. Now in the question they had given that angle ACB is obtuse. And we know that obtuse angles lie between 90 degree and 180 degree. But 81 becomes acute now. So to get this as an obtuse angle, we are going to subtract this value from 180 degree. So we get, so here 180 minus 81.02 gives us 98.98 degree, or rounding it to one decimal place, we can write it as 99.0 degree. So this is the value of obtuse angle ACB. Now let us move on to the next sub question. Part of the field triangle ACD is sold for $41,500. Calculate the cost of 1 hectare of this part of the field. Give your answer correct to the nearest dollar. And they have given a hint over here that 1 hectare is equal to 10,000 square meters. So let us again consider the figure given in the question. Now here they have said that part of the field, that is this part, triangle ACD, has been sold for $41,500. So let us try to find out the area of this triangle first. And to find out the area of the triangle, we are going to make use of the formula. Area of triangle is equal to 1/2 times A times B times sine of angle C. Now in this formula, A and B stands for the two sides of the triangle whose values are given, and C represents the angle which is given between these two sides. Now in this triangle ADC, the two sides which are given to us is AD and DC. So we have written here 1/2 times AD value is 420 times DC value is 830 times sine of the angle which is in between them, that is sine of angle D, sine 106. Now let us see what value this gives us. So this is going to give us the value of area of triangle as 167,547.9136 square meters. So here we have got the area of the triangle ADC. So this area is being sold for $41,500. Now since here we have to find out the area in terms of hectares, let us first convert the square meters into hectares. Since 1 hectare is given as 10,000 square meter and we have got this value for square meters, we are going to find this area in terms of hectares by just dividing this area by 10,000. So here we are going to get the area in hectares as 16.75479136 hectares. Now I can round this value to 3 or 4 decimal places to maintain maximum accuracy. Now once we have got this area, this means that this much area has been sold for $41,500. So what is the cost of 1 hectare of this field? So for that again we are going to make use of a cross multiplication method. So here for this area in hectares we have paid $41,500. Then for 1 hectare, how much is the cost going to be? So we are going to multiply these two, that is 1 multiplies with 41,500, and this value of the area divides this multiplication. So we are going to get the value as $2,476.9. So this is the cost for 1 hectare of this area. Since we have been asked to round it to the nearest dollar, we are going to round this value as $2,477. So let me write here. The cost of 1 hectare of this part of the field is going to be $2,477. This is its value. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.